Alright, Langston Hughes, we're back on it again. We're trying to learn something new again today. We're going to start off with the Binomial Theorem. Now, this is it could be a kind of confusing process, but with a little work, I'm sure we can get it. This is actually a shortcut, believe it or not, to a longer process. So, let's jump right into it. Let me give you a couple definitions that y'all need to understand, and then we'll work right into it and doing some examples. So, step one, what is the Binomial Theorem, and what terms do I need to understand how to do the Binomial Theorem? First thing we need to understand, we're going to be using the Pascal's triangle. Your Pascal's triangle is going to really make the Binomial Theorem easy. So what is the Pascal's triangle? It is a triangle array of the binomial coefficients. Now this is very important. Coefficients. Now what are coefficients again? Does anyone remember? Well, let me just give you an example. If I have 2m plus 1, right? Simple binomial. This is going to be the coefficient, and this is going to also be a coefficient, okay? Coefficients are always the number in front of the variable, okay? Or sometimes you don't have a variable here, but really this variable would be m to the 0. So really it's m to the 0 is always 1, but it's an understood m to the 0. And we learned that from, where we learned that from? Even and odd functions, right? So now the theorem, the beef of what we're learning. The theorem is used to expand x plus y to the n. Now, we've only been doing, for example, let's say 2x plus 2 to the second power. But as you see, this n could be to the third power, fourth power, fifth power, sixth power, 10th power. And we can go on. And we can make a sum involving terms of form ax to the b, y to the c, where b plus c is equal to n. Now this b plus c, which is very important, is always going to equal to n. So b plus c is going to add up to be n. Now of course this formula looks really, really scary, but we're not going to really be using this formula, but I want you to understand what this formula actually says. It's the sum, which is the summation sign, a plus b to the n, right? This is kind of where we're trying to get to, right? A plus b to the n is going to be equal to the sum of the combination, and actually for this formula, they use combination to do this formula. A to the n minus r, b to the r. Now everybody knows what combination is. We've been doing combination permutation for the last forever, so you should know what combination is. But just to bring you down a little bit and not have you scared, we're not going to be using the combination at all. We're going to be actually using the Pascal's triangle. Like I said again, the Pascal triangle is the beef of what you're going to learn. So before we even start into actually showing you how to do the Binomial Theorem, let me show you how to make the Pascal's triangle. So Pascal's triangle. Now the Pascal's triangle, as you see, they got ones all over the place, right? So you put a 1 here, and you put 2 1s, and now when you have those 2 1s, you add what's inside of the, you add these two together and you put it here. So 1 plus 1 gives me 2. Now put a 1 on the outside, right? So now we're going to add what's inside. 1 plus 2 gives me 3. 2 plus 1 gives me 3. And we follow the same pattern. Put a 1 on the outside. 1 plus 1 gives me 4, right? 3 plus 3 gives me 6. 3 plus 1 gives me 4. Put a 1 on the outside. Add the middle. 1 plus 4 gives me 5. 4 plus 6 gives me 10. 10, 5. Put 1 on the outside, add the middle. Right? Put a 1 on the outside, add the middle. So we get 6, 15, 20, 15, 6. Put a 1 on the outside, add what's in the middle. So that'd be 7, 21, 35, 35, 21, 7. Put a 1 on the outside, add a middle. 1 on the outside, add the middle. So 28, and that would be 56, 70, 56, 28, and 8. Now, as you see, you've made the path of the triangle, and we can keep going. This is only, these are the certain levels that we got. This is level 8, 7, 6, 5, 4, 3, 2, 1, and 0. So this comes into play, for example, these coefficients come into play for this, for example, this. A plus b to the 0 power. I only have one coefficient. It would really just be, what's a plus b to 0? 1. A plus b to the first power is just going to be a, 1, and 1, which is really equal to a plus b, right? Just one of those. Now for this one, I got 1, 2, and 1. It's going to be the coefficients used to do a to the second power. And then a, b to the third power. And then a, b to the fourth power. So the line, these rows correspond with which thing? Which thing? Of course, these exponents right here. So the 1 goes with this row, the 2 goes with this row, the 3 goes with this row, and the 4 goes with this row. Okay? Now, I'm pretty sure at this point you're still kind of unsure where this all comes together. But first, I need to make sure you understand how to make the Pascal's triangle. Say it again real quick. Put 2 1s, put 1 outside. 1 and 1, 2. At the inside. Just like that, 1 outside. 3, 3, and we just keep going, right? Same process we've been doing. Put a 1, 2 1s outside, and then add what's inside. Okay? So, let's move on to the next thing now. So, now that you understand how to make the Pascal's triangle, let's go over the steps on how to actually do the binomial theorem. So, first thing first, based on the exponent, which I just showed you a minute ago, find the coefficients that correspond with the problem. This is where the Pascal triangle comes into play. This is kind of like, this is your bread and your butter right here, the Pascal's triangle. Next thing, the first monomial in the binomial expression, use the exponent in the problem and count down to 0. So if you're, for example, if you're at 3, you want to count from 3 all the way down to 0. And on the second monomial, you want to count up. So from 0 all the way up to the exponent that you got, and then you want to simplify and multiply down. So this now all sounds great, but let's see an example so that way you can get everything that makes sense. So that way everything will make sense. So first things first, what are we trying to expand? We are currently trying to expand this right here, right? And let me change color for a second. We want to expand this. So we got to figure out what exponent corresponds with what row on the Pascal triangle. So this is a 2. So we got to go here. We got to go at 2. Now remember, it always starts at 0. So 0, 1, 2. So remember, it starts at 0. So this right here corresponds with the coefficients of, this corresponds with the exponent that we have, right? So 2, 2. Now let's pull the coefficients out. So we got 1, 2, and 1. Okay? So we're going to take the first monomial, which is, in this situation, which would be x. And we're going to count from 2 all the way down to 0. So this would be x2, x1, and I'm going to put parentheses around here. Right now it doesn't make sense, but you'll see how it's going to make sense later. And then x to 0, right? Now we're going to take the second monomial, which is 2, and we're going to count down to 2. So it would be 3, and we're going to go, we're going to start at 0, and we're not count down, we're going to count up to 2. So 3 to the 1, 3 to the 2. Alright? Now I like to draw a line, and I like to simplify what's up here. So this right here, you really never touch this line. This one you just always bring it down. Alright? X squared, just be x squared. This right here, just be x. X, anything to the 0 power, like we said earlier, would just be 1. Okay? 3 to the 0 would just be 1. 3 to the 1 would be 3. 3 to the 2 would be 3 squared. 3, not 3 times 2, but 3 squared would be 9. Now if we multiply this straight down, x squared, multiply this, I get positive 6x Multiply this down and get positive 9. Now that's our answer. Our answer will be x squared plus 6x plus 9. So as you see here, instead of doing the box method, I can actually do the binomial theorem, and it'll work out perfectly fine, right? Because x squared. Now, let's do another one. Example 2. Now we gotta figure out the x one that corresponds, with the Pascal triangle. So which x one that corresponds with the Pascal triangle in this situation? We have a 3 here, so it's going to be this 3 right here, right? So we're going to take this out. 1, 3, 3, 1. So I'll take our first monomial, and we're going to go at 3, and we're going to count all the way down to 0. So it would be x to the third, x to the squared, x to the 1, and then of course x to 0. Then take our negative 4, bring it here. Negative 4 is going to be at 0. Negative 4 to the 1. Negative 4 to the 2. And negative 4 to the 3. Draw a line. After we draw a line, we're going to try to reduce everything above it. Now, I'm going to change color on this. I'm going to make it blue. This right here always stays the same. This line always stays the same. It never changes. So now let's simplify this. X to the third would be x to the third. X squared would be x squared. This right here would just be x. This right here would just be 1, right? Now negative 4 to 0 would just be 1. Negative 4 to the first would be negative 4. Negative 4 squared would be just 16, right? Negative 4 times negative 4. And negative 4 to the third would be 64. Yes, it would be actually negative 64. Now we multiply it down, we get x to the third. 1 times 1 just gives me 1. 3 times 4 gives me negative 12, and I bring my x squared down, right? 3 times 6 is positive. This will give me a 48. Bring my x down, and this gives me a negative 64. Now this is my answer right here. So my answer is x to the third minus 12x squared plus 48x minus 6. And now this is my answer. Alright? Now, let's go one more step. Now let's go into example 3. Example 3, actually I think example 3 is just like example 2. So let's go one more step. Let's do a little harder one. Example 4. So now example 4 looks a little bit tougher. It's got the 2x and the 3 here. Man, it looks kind of hard, right? Well, let's follow the same steps. Let's go ahead and circle what we need to circle. So the 3 corresponds to which line? As we say in the Pascal triangle, would also be 3. Right? So let's go ahead and bring it down. So 1, 3, 3, 1. Right? That's the first thing. Now we're going to bring our monomial. So the first monomial, and we're going to do 2x here. And we're going to start at 3, and we're going to count all the way down to, as we said earlier. So 2x to the 2, 2x to the 1, and 2x to the 0. Done here. Then take a second monomial, and we're going to do 3, and we're going to start at 0, right? 3 to the 1, 3 to the 2, and 3 to the 3. Now if I change this, now I'm going to simplify what we have, what we just put down. So I'm going to go to orange. The top always stays the same. Always stays the same. So now, this is the reason why I put the parentheses around here, right? 2 to the third doesn't give me 6, it gives me 8x to the third. 2 squared gives me 4x squared. 2 to the first gives me 2x. 2x to the 0 just gives me 1. 3 to the 0 gives me 1. 3 to the 1 is 3. 3 squared is actually not 6, but 9. 3 to the third is 27. Now all we got to do now is multiply straight down. 8x to the third plus 3 times 3 is 9. 9 times 4 is 36x squared, right? Plus 9 times 3 is 27, times 2 is 54x, and last but not least, plus 27. Now this is our answer. So now just imagine if we were to do this three or four times. That would be a pain. We just broke this down and we got our answer just that quick by using the binomial theorem. So like I say again, this is a shortcut. The only thing you need to make sure you understand is how to create the Pascal's triangle. This right here will help you solve the whole binomial theorem and everything will go perfect. Alright, so this is what we learned today. We learned the binomial theorem. Hopefully you guys understand it. The only key thing I'm going to say is make sure you put your little quotes, put your parentheses around each of these and make sure you simplify. As you see here, 2 to the third gives me 8. And that's a simple mistake a lot of people make, and you always want to multiply down. Okay? Alright, hope this helps, and I'll see you guys hopefully tomorrow. Have a good day.